Hi guys, I'm Ben, and today I'm going to be showing you guys a demo of my project, which is Chip8. Alright, so let's dive in. So Chip8 is an emulator architecture, or I guess virtual machine. So what it is like there's a set of instructions and people can implement it and stuff. So here I have an implementation of the instructions. And if you're confused about these errors, I wrote this code on a Linux machine. I was running Pop OS, but now I switched to Windows because battery on Pop OS and any Linux distribution absolutely fucking sucks. But alright, let's start up. First, we got some defined macros, just stuff like memory, register count, and here's the important stuff: memory. It's just program memory. It's 4096 bytes. It's about a gigabyte or a megabyte. I don't care. And then we have a V. There's just a bunch of registers. So V1, V2, V3. So 16 registers. And I believe there are 8 bits each. Yeah, 8-bit registers. And we have a 16-bit whatever it is. Instruction counter, pointer, whatever. And then we have a program counter, we have delay and sound timer, and we have what's 16 times 16? I'm not gonna do that math. Maybe leave it in the comments. But basically that's a pretty big stack. It's around like 5 megabytes or something. And we have the stack pointer. That's how you traverse the stack, because there's literally no other way. But these are there's just the graphics buffer and the key input buffer. And here we have our font set. It's basically just a bunch of 8-bit characters. That's how we read and draw fonts into the thing on the screen. And so initialize. So initialize, it just sets program counter to hex 200. That's where the program starts. If you're confused about what's before that, the font set is loaded in before that. You can see that here. 80 bytes, hex 200, whatever. Anyways, so we're just clearing this the registers, memory, and stack, and the graphics and key buffers, and we're setting these to 0. And we're just gonna do some video in it. And this is just the draw graphics function. Oh yeah. So it just goes through the graphics buffer and draws it to the screen. And this is just mapping key codes for input. Alright. This is where the program starts. You read the file from the argument into memory at hex 200, because if you guys remember, that's where the program counter is, and that's where the program starts executing. And then close the ROM, and this is where you just consistently read opcodes and stuff like that. And yeah, so at the end, you're just gonna wanna set running equals 0, stuff like that. Yeah. But alright, so we got the binary here, and I'm running WSL because the final distribution was compiled for Linux, because at the time I was still running a Linux machine. But anyways, let's start up. So here I have the binary here and the program here. So let's start /chip8 stuff.j, and then just draw some random stuff. I did not write this program. I just found it off the internet. Well, I didn't write the this stuff.chip8. Hold on. Cat. Yeah, it's just a bunch of bytes. But size stuff.chip8. Come on, man. It doesn't even have basic shit installed. Yeah, this is crazy. It's WSL. I'd rather use normal Linux. But enough about me complaining about Linux. Just tell me what you think in the comments if I have comments enabled, and you know, subscribe if you want, and leave a like. I'll see you in the next one.